Welcome to the first module of our Prolog course. Prolog is a programming language, but it is more than that, it is a different way of thinking about problems. Over the next 20 minutes or so we will see what makes logic programming so distinctive, why a language created more than 50 years ago is suddenly relevant again in the age of AI, and how the ideas in this module carry all the way through to building a working knowledge engine at the end of the course. Let's begin. Here is what you will be able to do by the end of this module. First, explain clearly how declarative programming differs from the imperative style you already know. Second, read and write the three basic building blocks of any Prolog program: facts, rules, and queries. Third, describe horn clauses and the first-order logic that Prolog rests on. And fourth, recognize where logic programming fits in the modern AI landscape, from knowledge graphs to neurosymbolic systems. Keep these four goals in mind as we go. Here is the single biggest shift you need to make. In the languages you have used so far, you tell the computer how to compute an answer, step by step. In Prolog, you describe what is true about your problem, and you let the system work out the answer for you. You move from being a director, dictating every step, to being a describer, stating the facts and the relationships. That one shift is the heart of everything that follows in this course. Let's make that concrete with a simple question: who is Lucy's parent? On the left is how you would solve it in Python. You design a data structure to hold the relationships, then you write a function that loops through it, checking each entry until it finds a match. Around 18 lines, and you had to invent both the data layout and the search algorithm. On the right is Prolog. You simply state the facts, who is whose parent, and then you ask the question directly: parent of X, Lucy. That's it. You never wrote a loop and you never wrote a search. Prolog finds the answer itself. Notice what happened: in Python you spent most of your effort on the how. In Prolog you only described the what. Let's name these two styles properly. The imperative style answers the question: how do I solve this? You initialize variables, loop over data, check conditions, change state, and return a result. C, Java, and Python all work this way. The declarative style answers a different question: what is true? You define facts, define rules, pose a query, and the system infers the answer. Prolog, SQL, and Haskell live here. The core difference is this: imperative code is about process, the steps; declarative code is about relationships, the logic. Prolog lets the computer find the answer on its own. Why is this worth your time? A few real strengths. Your code reads like a description of the problem itself, so it is unusually clear. You focus on domain knowledge instead of control flow. The system searches for answers automatically, change the knowledge base and you do not rewrite an algorithm. And queries run in both directions. The same parent relation can find someone's parents or their children, just by where you put the variable. Now the honest limits. You have less direct control over the search strategy. Careless recursion can loop forever. We will spend real time on that in later modules. It is not the tool for heavy numerical computing. And debugging means understanding how Prolog searches. Where does it shine? Knowledge representation, expert systems, natural language, theorem proving, and constraint solving. Prolog rests on first-order predicate logic, and its vocabulary is small. A predicate names a relation or a property, parent, with two arguments, written parent/2. Constants name specific things and start with a lowercase letter: John, Mary. Variables stand for the unknown and start with an uppercase letter: X, Y, person. And a term is the general building block: an atom, a number, a variable, or a compound structure. The number of arguments a predicate takes is called its arity, and arity matters. Point with 2 arguments is a different predicate from point with 3. Get comfortable with this handful of distinctions and the rest of the syntax follows. Everything in a Prolog program is one of 3 kinds of horn clause. A fact is an unconditional truth, just a head, ending in a period. A rule has a head and a body, joined by the turnstile, which you read as if, the head is true if the body is true. And a query has only a body, it is the question you ask, written with question mark dash. Horn clauses are a restricted form of logic, with at most one positive conclusion per clause, and that restriction is exactly what makes Prolog's reasoning efficient and well-behaved. Simple pieces, powerful combinations. Here is your first complete Prolog program. 2 facts: John is a parent of Mary, and Mary is a parent of Tom. 1 rule: X is a grandparent of Y if X is a parent of some Z, and that Z is a parent of Y. Now we ask, who is John the grandparent of? And Prolog answers, Tom. Look closely at what just happened. Nowhere did we store the fact that John is Tom's grandparent. Prolog derived it, on demand, from 2 facts and a rule. That ability, to compute new knowledge from what you already know, is the whole point of logic programming. How did Prolog actually find that answer? 2 mechanisms working together, and we will devote a whole module to them later. The first is unification, making 2 terms match by binding variables. Ask parent of John, X, and Prolog lines it up against the fact parent of John, Mary, and binds X to Mary. The second is backtracking. Whenever a path fails, Prolog automatically backs up to the last choice and tries another, an automatic depth-first search through your knowledge. The overall algorithm has a name, SLD resolution. For now, just hold the intuition, match, and when you get stuck, back up and try again. We will open up this engine in Module 3. A quick word on where Prolog comes from, because it explains a lot. It was created in 1972 by Alain Kalmerauer and Philippe Roussel in Marseille, and it was born out of a problem in natural language processing, getting machines to reason about human language. It spread through the December 10 implementation in the late 70s, rode a wave of investment in Japan's 5th-generation computing project in the 80s, was standardized by ISO in 1995, and today it is enjoying a genuine revival as interest in neurosymbolic AI, combining logic with machine learning, comes back. A language designed to let machines reason with human-like knowledge, which is exactly why it is interesting again now. So why learn it in this course, today? 4 reasons. It trains a relational, declarative way of thinking that will make you a sharper problem solver in any language. It is the clearest entry point into symbolic AI, the logic and knowledge tradition. The very same ideas power knowledge graphs, the semantic web, and the rule engines running behind many real systems. And it sits at the heart of neurosymbolic AI, where logic and learning meet. This is not a museum piece. The skills you build here lead directly to the Knowledge Engine module at the end of this course, where we will represent an ontology and reason over it, in Prolog. Here is the road ahead. We start, in this module, with the big idea. Module 2 introduces the building blocks, facts, rules, and queries, in depth. Module 3 opens up the engine, unification and backtracking. Modules 4 and 5 are about recursion, first the concept and then real examples with numbers, lists, and structures. Module 6 looks at why the order of your clauses and goals matters, with some famous traps. Module 7 covers lists, arithmetic, and control. And we finish, in Module 8, by turning Prolog into a knowledge engine, knowledge graphs, ontologies, and reasoning. You are here, at the start. Let's build. Let's pull the threads together. Logic programming means describing what is true and letting the system infer the rest. A Prolog program is made of 3 things: facts, rules, and queries. Underneath sits first-order logic, expressed as horn clauses. The engine that runs it all is unification plus backtracking, together called SLD resolution. And the big picture view to carry forward, Prolog is, at its core, a knowledge engine. In the next module we will get hands-on with the building blocks, facts, rules, and queries.